Hello everyone, I'm called Dr. Mayur Kumar Chipa and I'm active IEEE member under IEEE Uganda section, IEEE region 8, and in the month of June 2028 I have successfully completed my PhD, which is based on 2D photonic crystal based devices for photonic integrated circuits. And the main purpose to apply for these grants for IEEE region 8 AI doctorate symposium at GTEx is all about the way we have applied the concepts of machine learning and artificial intelligence to optimize the parameters or the designing parameter for our devices in such a way. Recently we have published in the month of 2023 one of our paper, which is a collaborative paper with IEEE Axis, and which is based on the title Orbital Angular Momentum Mode Propagation and Supercontinuum Generation in a Soft Glass Bragg Fiber. So in this, the proposed Ring Core Bragg Fiber is a very versatile structure demonstrating its application in optical communication and optical coherence tomography. Photons carrying orbital angular momentum modes have been explored to be used for quantum communication. Since the fiber shows the successful propagation of orbital angular momentum modes, the Ring Core Bragg Fiber can be an ideal candidate for quantum communication applications. Further, the OAM modes carrying fiber can also be explored in the domain of high resolution imaging such as STED microscopy. The fabrication feasibility has been also discussed in this paper, as the materials which have been used have a high glass transition temperature, low thermal expansion coefficient, and high thermal conductivity. So when we look at for the unique contribution of our published work with an IEEE Access journal is, here we have proposed a compact and practically feasible photonic crystal fiber structure derived from a Bragg lattice. The fiber structure consists of a ring core and alternating layers of high and low refractive index materials. These materials, short SF57 and short LLF1, are chosen carefully owing to application and fabrication feasibility by considering the parameters such as high nonlinearity and thermal compatibility respectively. The design fiber presented in our published paper falls into a specific class of optical fibers with multiple applications. The fiber successfully demonstrates the propagation of orbital angular momentum modes, which are an essential component of quantum communication, and the future is there for the quantum communication. And this supercontinuum light can be used in various real-time optical coherence tomography applications. In addition to the application in the quantum communication domain, and due to the high nonlinear nature of the material used, the fiber also demonstrates the generation of supercontinuum light with a flatness of approximately 33 dB. When you look at for the scope of this work, we intend to focus our efforts on a Ring Core Bragg Fiber that demonstrate application in communications and high resolution imaging through supercontinuum generation. We design and propose this structure with alternating layers of highly nonlinear materials made of fluent glasses. Supercontinuum generation involves the spectral broadening of the input pulse due to several linear and nonlinear processes. The proposed fiber, after optimization, demonstrates the propagation of 24 orbital angular momentum modes and hence become a viable candidate for applications in communications as quantum communications. In a nutshell, the proposed structure is a high-performing practical design that demonstrates the propagation of OAM modes as well as the generation of supercontinuum light for high resolution imaging. Thank you so much for my application. Hope to be in Dubai very soon.